Module 2 Traffic Engineering Lesson 2.1 Elements of Concern and Components of Traffic Systems. After completing this lesson, the student will be able to develop a general understanding about traffic engineering, identify various elements of concern in traffic engineering, and the student will be able to identify various components of traffic systems and appreciate their role in traffic engineering perspective. Introduction. Let us first of all try to understand the subject area traffic engineering. What is traffic engineering? Traffic engineering is that phase of engineering which deals with safe and efficient movement of people and goods on streets and highways. So, it deals with safety and efficiency of movement of people and goods on road system, that is street and highways. Institute of Transportation Engineers defines transportation engineering, defines traffic engineering, that phase of transportation engineering which deals with planning, geometric design and traffic operations, measure these three aspects on road system, that is road, streets and highways, their networks, terminals, abutting lands and relationships with other modes of transportation. That is the way IT, Institute of Traffic Engineer, defines traffic engineering subject. With this background definition, let us now try to address some of the basic issues in traffic engineering perspective, basically to create our mindset about the traffic engineering elements. First issue is whether it is person movement or vehicle movement. Often we face this confusion in traffic engineering, what is our primary concern or real concern, whether it is person movement or movement of vehicles. It is worthwhile to mention that the real concern is movement of people and goods. So, moving people and goods is the real concern. Obviously, movement of vehicle is just a way of accomplishing this. So, primarily people need to move from one place to another place. So, movement of people and also goods are to be transported from one place to another place. So, primary concern is movement of people and movement of goods. How these people or goods are transported? Vehicle is the means for that. They are transported in vehicles. So, vehicle comes afterwards and it is the resulting volume that is creating road congestion and creating many peripheral problem in traffic engineering. But let us not forget that primary concern is movement of people and movement of goods. Of course, it does matter the way it is transported in vehicles. So, we cannot really deny the road of modal split, that means how the demand is distributed into different modes and other modal characteristics. So, therefore, it is worthwhile to mention that it is necessary to appreciate the mode of transport and type of roadway used for moving people and goods. What is the effect of mode? What is the effect of roadway type? What is the effect of mix of traffic? All three aspects are also important. A road system, if it is carrying, say, in terms of, let us consider the movement of people. So, some k number of people are to be transported. If all of them they use car, obviously that means a very large number of cars on roads and highway system, and probably that means very high level of congestion. But all the people, if they use public transportation system, say bus transportation system, obviously relatively much lesser number of buses will be required, and probably the road will apparently appear free and not suffering with acute congestion level. So, definitely modal split, or the way the demand is distributed into different modes, that has a very vital role to play in the overall traffic engineering perspective. Similarly, all the roads, they do not serve the same purpose. The way the road system functions, it has really got an impact on the overall performance or quality of service that is offered by the road system. Some roads may be providing multiple access, from any place you can enter into the road. So, that creates substantial disturbance to the moving traffic stream. So, obviously, in a system where you are allowing entry and exit at any point, where you have lot of pedestrian activities around, vehicles are parked on street, it has got all these elements, they will affect the quality of traffic operation on road system. So, obviously, effect of roadway type is also important, and we cannot also deny the effect of mix of traffic or the traffic composition in the overall traffic engineering perspective. The way the demands are distributed, it is the same road space which is used by cars, by buses, by commercial vehicles, again light commercial vehicles, heavy commercial vehicles. So, way the road system accommodates traffic, the nature of traffic, the mix of traffic, it really matters, or it really influences the performance or overall the characteristics of traffic operation. So, effect of mode, effect of roadway type, and effect of traffic mix, all these three are very important in traffic engineering perspective. Now, the second question is goods movement and or person movement. In many occasions, we think that road is primarily for passenger movement. That means, we see often cars are getting congested, cars are car volume, with the car volume roads are getting congested, and presence of a few commercial vehicles like trucks or other heavy vehicle types, their presence even aggravate the traffic congestion problem. So, we apparently think that road is primarily for movement of passengers, and trucks or good vehicles are some sorts of disturbing elements in the overall system, because really they do create problem. But let us not forget the fact that goods transportation provides the lifeline to any community. It directly adds to economic development. It is necessary to transport the raw materials, and it is also necessary to transport the finished product. Both are important. So, we must not forget the role of goods transportation in the overall transportation engineering sphere and their role and their contribution in the overall economic development. So, we have to consider and we have to take care of the passenger transportation as well as goods transportation. Both are important. So, I have indicated like this: road primarily serve to motoring public. Is that the trucks are problematic elements? The answer is no, because goods movement is critical to the local economy. Transportation of raw material and the finished products both are important. So, therefore, goods movement and person movement both are essential. Next is the mix of vehicle in person movement. Person movement is normally accomplished by sharing the demand into different types of modes. So, in the context of traffic engineering, our focus is generally on movement on streets and highways. That means, we are excluding for the moment the rail transportation, water transportation and air transportation scenarios. So, within and between cities and towns, people normally move in a mix of vehicles, namely private vehicles, buses, paratransit systems and bicycles, even walking. So, different modes of transportations do exist. Each mode of transportation has its own utility in the overall system, starting from walking to movement by bicycle or non-motorized transport to faster travel, even the car movement, the bus movement. Okay. So, every vehicle type or every mode has its own utility and contribution in the overall transportation system. So, we have to consider all of them, and the beauty of the road system is the same road space or whatever is the available road space, we have to use them for movement of various vehicle types. Okay. In certain context, we may restrict some type of vehicle movement on certain roads during certain periods, that is a different question, but all vehicle types are to be accommodated. And if we look at the developing country context in particular, in developing country context, heterogeneous traffic movement is very common. In most of the developing countries, the traffic movement is heterogeneous, and heterogeneous traffic movement, it adds to the complexity of traffic operation, and it makes the traffic engineering a more complex task in developing country context. Now, with that background, let us look at the various elements of concern. Basically, through this part, we would like to develop our understanding about the traffic engineering. Now, it is probably easy to develop concept and understanding if we discuss the major concerns or the elements of concerns. 5 major elements are shown in this flow chart. You have system of facilities, basically the road system. We shall discuss in details about each of these components. So, we have supply side or the system of facilities, we have demand, and they interact with each other in a transportation system in the interface of control, and they create, this interaction creates operational performance, congestion and all sorts of other things. So, influencing the demand is another aspect. Can we influence the demand? Should we influence the demand? If so, then in which ways? Then measuring the performance of the overall transportation systems, and then transportation systems management. So, these are the 5 major elements of concern, and let us try to understand each of these elements in details. First, system of facilities. System of facilities normally include the physical road system. It is essentially the supply side of a transportation system. So, it includes roads which are used for moving vehicles, parking areas, terminals and all other physical facilities, and it also includes the control devices which are present on roads. For example, signs, signals, markings, these are all physical facilities. So, they come under system of facilities. So, system of facilities include both roadways for moving vehicles, parking areas and terminals for transferring passengers and or storing vehicles. Now, in this context also, we know that road systems in urban areas, in rural areas, they are different. They are different, fundamentally they are different. The type of system, the purpose, they all may be different. So, primarily we consider two types of road system, urban areas and rural areas. Rural means essentially non-urban areas. So, normally we call them as rural roads or rural areas, highway roads in rural areas. Now, further classification of facilities for moving vehicles in rural and urban areas are done based on functional classification. That is again an important aspect. Not that all roadways, even an urban area or even in a rural area, they serve the same purpose. Two aspects are important. A road may serve for the purpose of providing access, and then it may also serve for the through traffic movement. That means faster movement of long distance traffic, through traffic. So, often these two aspects are important. How much a road is there for providing access and what extent it is supposed to handle the through traffic movement. So, these two functions, measure these two functions and their level of influence, that may define functional classification of roads. We define a hierarchy of roads where in some cases the whole objective is through traffic movement, in extreme end the whole purpose may be providing access, and there could be other types of roads which serves a combination of both these aspects, some may be more, some may be less. So, that functional classification is important. We shall also learn the functional classification in due course of time. Then we have control devices. These generally establish the character of the road. These control devices include traffic signs, traffic signals, road markings, and all these are essentially for communication to drivers and establish control over the traffic. Controlling the traffic or looking at the operational aspects of the traffic is also important. How to improve the efficiency of traffic operations for a given facility and a given demand system. So, there the control devices will play a vital role. So, this also includes or defines the system of facilities. Then second aspect is the travel demand. We all know that demands are generated by activities. People live somewhere, they need to travel to various places, places of work, places of shopping, places of recreational facilities. So, for different purposes they need to travel, and there is a spatial distributions. Residences are located somewhere, activities are located somewhere, and that is what generate the travel demand. The spatial distribution of activities, they generate demand. So, that is, and demand, because demand is there, we need to provide supply, and supply also influence the demand pattern. So, it is a two-way interactions. So, it is basically generated by activity, and both spatial and temporal characteristics of distribution of demands are important. Let us try to understand the spatial and temporal distributions of demand. As I have already indicated, because the facilities are located in a different places, it has got a spatial characteristics. So, naturally demand has also got a spatial dimension. If offices are located somewhere in the CBD, if residences are located in the suburb, then it is often or obvious that during the morning hours, peak hours, the travel will be from residences to the CBD area or the office area, and in the evening people again need to come back. So, there will be demand between office areas or the CBD to suburb. Obviously, when this, not that all places are equally loaded over the whole period of time. Some roads are loaded, some are free, and at some other time maybe congestion is there, some time there is no congestion on the road. So, it varies over distance, over space, space means the area, and it also varies over time. If you think again the earlier example, people are going to office, so maybe between 9 to 10 all the roads towards the CBD area, they will be congested. If you see, maybe at 12 o'clock those roads are not congested, because primarily they serve demand towards the CBD area or where main offices are located. So, the same road, whatever you find at 9 o'clock, it is highly congested, at 12 o'clock there may not be any congestion on that road. So, demand has got both spatial and temporal characteristics, and this is to be understood very clearly if we have to address the traffic engineering and the related issues. As I indicated earlier, mode selection is a crucial consideration, because for the same person demand or the passenger demand, mode selection or mode split decides the actual traffic volume and therefore, the actual level of congestion on road at a given time. Remember that the process of estimating true demand is often complicated by the fact that demand is frequently distorted or limited by the available capacity. All physical facilities are capacitated. If you think of a road, it can handle only certain number of vehicles or certain volume of vehicles. So, even if the demand is more, the road cannot accommodate any traffic volume higher than its capacity. So, it may be distorted, demand may be distorted or limited by the available capacity. And also demands are subjected to variation due to profile of populations, say income, vehicle ownership, gender, age and other socioeconomic activities or attributes. If you see the trip rate, the way or the per capita trip made in a day, the number of trips, it is influenced by income, it is influenced by car ownership. Normally maybe high income households, they make more trips, okay. High personal income means more trips, higher vehicle ownership means more trips, okay. So, all these socioeconomic characteristics also do affect or influence the demand pattern, and that makes the whole demand estimation a complex task. Next is influencing the demand. Now, traffic engineer's job often starts with a given pattern of demand. If you see, this is just an example. If we see the volume of traffic on a road and time versus time, you normally get a pattern like this. Sometimes you may be getting a pattern like this also, maybe two peaks. Morning when people are going to offices, that time you find the traffic volume is more, road is congested, and then the traffic volume comes down, and then again in the evening when people are coming back or going to shopping or recreational places, then again the demand is more. It is interesting to note that the capacity of a system is fixed as shown by this dotted line. This is a fixed value. So, capacity is fixed, demand most of the times it is maybe lesser than the capacity. Night time usually demand is practically nil, but capacity does not change, capacity still remains. So, it is only at certain hours of the day that demand is becoming more than the capacity and the congestion is created. So, it may be worthwhile wherever it is possible, wherever it is applicable, to think of or to influence this demand pattern to make a better use of the available capacity. Say only during 1 hour in the morning and 1 hour in the evening, the demand is more than the capacity, and we start thinking of widening the road to have a capacity level here. Now, problem is only during the 2 hours, 1 hour in the morning say for example, and 1 hour in the evening. Now, for that one, why to increase the capacity of the road system? Why to add more capacity? Because adding capacity, building roads is a very capital intensive solution. So, rather than can we touch or can we influence the demand, so that within the given road system, within the available capacity, we can have a better utilization of the capacity. So, that is why it is meaningful, it makes sense to influence the demand. There are 3 different ways that we can influence the demand. One is shifting the temporal distribution of demand. I have already mentioned that demand has got a temporal nature. At 9 o'clock the road is highly congested, at 11 o'clock it may be relatively free. So, it is basically shift the temporal distribution of demand, that one way we can influence the demand. Reduce the magnitude of the demand. Can you really reduce the magnitude of the demand itself? That will be very much meaningful in the overall perspective. Then another is repackage the demand. We shall discuss in details about all these 3 approaches. Now, the action taken to effectuate these goals of influencing demand is called transportation systems management, the other elements of concern that I have mentioned. Shift the temporal distribution of demand. By this time, I am sure you all will appreciate the problem may not be really too much demand, but the problem may be too much demand at the same time. If you see in the midnight, early hours in the morning, late hours in the night, the demand is practically nil. So, it is not that if you consider 24-hour span in a day, not that the demand is very high as compared to the capacity. Rather, the problem is too much demand at the same time. So, it does make sense to influence the demand by trying to shift the temporal distribution of demand. So, as the peak period is very largely a work trip peak, because most of the time morning and evening peaks, it constitutes of largely vehicles which are for work trips or people using vehicle for work trips. So, shifting of demand is really meaningful. What I mean by shifting of demands, rather shifting the peak hour demand. Mitigate the peak hour demand, let the total demand be even same, but can we distribute the peak hour demand over a larger period of time, so that at no hours the demand is more than the capacity. Reduce the peak, spread it over a longer hours. So, that can be achieved by staggered work hours, variable work hours. Now, again let us try to understand these concepts. Most of the cases you will find in a city or in a town, all offices maybe they are starting at 9 o'clock. So, you find if it is so, all offices are starting at 9 o'clock, you will probably expect everybody is going to office between 8 to 9 o'clock. So, 8 to 9 probably is generating maximum demand, that time demand is maximum and all the road systems are congested. Can we not think of a system where some offices may be starting at 9 o'clock, some are starting at 8 o'clock, some are starting at 10 o'clock, and accordingly the closing time also will change. Instead of 4 o'clock or 5 o'clock, some will close at 4 o'clock, some will close at 5 o'clock, some will close at 6 o'clock. Still there will be enough common times, enough common working hours for interaction, exchange of ideas, meetings and all sorts of other works. So, keeping sufficient gaps, sufficient overlaps, we can still stagger the time. If we do that, then there is tremendous benefit, because complete demand is served in a better way with the same road system, same facilities, capacities, and people enjoy a better quality of service. Roads will definitely become lesser congested by this mechanism. Flexible working hours. So, in a office also there could be different slots. Somebody may pick up a slot from 8 to 4, somebody may pick up a slot from 9 to 5, somebody may pick up a slot from 10 to 6. So, often these kinds of flexi hours, it gives advantage, benefit to the job makers also, to persons who are employed, because they can accordingly schedule other activities. Maybe husband and wife both are working, one can go bit early in the morning and he or she will come back early, the other can go at a late hours, maybe they will start the office at 10 o'clock and they will come, he or she will come late. So, that way it is beneficial for the employee and it may bring tremendous benefit on the traffic operation, road system and the overall performance of the transportation systems. So, if you look at the benefits, reducing peak hour load through all these mechanisms and making more efficient use of capacities of roads and also the transit system. So, transit system also most of the times you will find during the peak hour transits are overloaded, buses are completely loaded. So, if we stagger the demand, if we can stagger the demand rather, then the load on transit system will also be reduced, will also spread over a longer time. So, benefit will be less crowding on transit and better utilization of capacities. Now, reduce the magnitude of demand. How can we reduce the magnitude of demand? Remember that travel demand may be measured in terms of some combination of total trips and also length of trips, say person kilometer travel. That in fact, this is a proper more rational quantification of demand. If we say only how many number of trips, we may ignore whether they are short trips, long trips. So, if we consider a combination of total trips and lengths, say person kilometer, that gives a rational and balanced measure of the magnitude of demand. So, magnitude of demand may be reduced by following ways: shorter work weeks, shorter average trip length, and more work at home. All these are possible, nothing is impossible. Shorter work weeks, instead of maybe 6-day week, it may be 5-day week. The total working hours in a week still remain the same. So, if some offices operate on a 5-day schedule and some offices operate on a 6-day schedule, obviously the starting and closing time will be different. 5-day weeks means it will be longer working hours in every working day. 6-day weeks means relatively shorter working hours in every working day. So, all people will not go to the office in the same time. So, that will again bring benefit. So, we are reducing the demand during the peak hours, and there are benefits, number of benefits from that. Shorter average trip lengths, job shift to smaller cities and decentralized location. In many cases, in most of the cities in developing countries, you will find all offices, all head offices are located in the capital city. Maybe majority of them are required to be located in capital city, but in many cases you can probably all the people from the states, they need not come to the capital city. You can have district headquarters or zonal headquarters, so decentralize it. Decentralize it so that people do not require, all people do not require to travel to the CBD area or to the same town for each and every work. So, that may reduce the total demand. More works at home, this is also a feasible option, because with the development of computer, networking facilities, many things can be done in office, in home end also, and that can substantially reduce the overhead cost for physical facilities. A big office in a very expensive area or zone where the land use or the rental is very high, a smaller office can be there, but the productivity can still be comparable. People can work in home, they can exchange idea, they can interact, and not that every day everybody will go to the office. It may sound very surprising, but it may be possible, because if you have computer, if you have network, not that for every office, for every system, every type of industry it will be possible, but it may certainly work for some of the industries and some of the types of job, at least for some employee. So, if we try to make use of these computers and networking facilities, certainly we may be able to reduce the demand, travel demand, at least to some extent. Repackage the demand. Remember that we are talking about repackaging, that means total demand still may be same in terms of person movement, but we are trying to repackage the demand. Let us see how we can repackage the demand. Through higher car occupancies, shift to transit and paratransit. So, what will happen? Same volume of passengers may be transported, but with a lesser number of vehicles. That means, it may be possible that you allow a vehicle to take a shorter route when the occupancy of the vehicle is higher, maybe for a car. At least there should be 3 persons if you want to use the shorter route. If it is only 1% or less than 3%, the vehicle will be forced to take a longer route. So, people will be encouraged to use higher occupancy or make higher occupancy of the vehicle. The result or the benefit to the community is substantial. 3 persons are traveling in the same vehicle. So, instead of 3 vehicles, it is now 1 vehicle. More people switch over to mass transportation system or public transportation system. So, again there is reduction in the vehicle volume, so lesser congestion on roads. So, benefits are multidimensional, benefits in terms of capacity utilization, benefits in terms of better mobility, better travel speed, better environmental aspects. Programs and rules to encourage carpooling, van pooling, express bus, park and ride, allocating limiting existing capacity to high occupancy vehicles. These are different ways and means for repackaging the demand. Carpooling is, instead of 3 persons taking 3 cars, they can and going to the same office area from the same residence area. Say it is a 6 days week, everybody is taking his own car to the office. Instead of that, if 3 of them they use carpooling and they decide every 2 days in a week one person will take his car and all 3 of them they will travel in the same car, because they start at the same time, they go to the same area. So, instead of 3 cars it is 1 car now. So, congestion is reduced, again all sorts of benefits may be achieved. Similarly, the van pooling, one vehicle and so many people are traveling in that same vehicle. This kind of repackaging may be encouraged by putting restriction to parking opportunities. If you take the vehicles, parking space is limited, you may not get a parking space, or you may have to park your vehicle at a much distant place, or there may be some kind of parking charges. These are all indirect ways and means to encourage people to use mass transportation system or use some sorts of repackaging facilities like carpooling, van pooling and other things. So, congestion pricing also could be taken as an instrument to encourage this kind of achievement. Measuring the performance, yes, it is necessary to understand how well a facility or system is working. It is necessary to understand. We need to understand it for various reasons. One, for assessing the existing congestion, how good or bad the existing system is, how it is operating. So, we must be able to measure the performance for assessing the existing condition, for evaluating alternative improvements. Suppose presently the situation is not that good and you were thinking of suggesting improvement measures. There could be 3 different alternatives. Now, how do we know which alternative brings maximum benefit to the community? We must be able to quantify it using proper measures. So, it is also necessary for evaluating alternative improvements, quantifying associated cost and benefit. Every alternative you say, it will have a cost. To do that, you will require some cost and it will bring some benefit to the community and road users. So, for quantifying the cost and benefit also it is useful, and for communicating results to both, observe it carefully, technical and non-technical audiences. You may be doing lot of engineering, you might be doing lot of other works, but finally you have to communicate the results to technical and non-technical audiences. So, if you can quantify it in a proper way and say, see, this is the benefit or this is the gain by this activity, it will be easy for others to appreciate your effort and accept the suggestion. Facilities generally assessed by specific quantitative measure and by a qualitative index of quality of flow called level of service. So, mostly we use this term to describe the quality of operation, traffic operation on a facility by level of service. Level of service is a qualitative aspect and it is normally expressed by a letter code ranging from A to F. A indicates the excellent quality, F indicates the worst or very poor or unsatisfactory operation, B, C, D, E are in between. Now, we often use a quantitative basis also for defining the level of service. Level of service is a qualitative term. So, we often use a quantitative basis also for defining the level of service, and that is known as measure of effectiveness. Measure of effectiveness is a quantitative basis for defining level of service. So, some of the common quantitative measures, they may be using many of these things may be used as measure of effectiveness. Volume or the flow rates traffic volume or traffic flow. We can express it in terms of maybe demand volume, in terms of maybe discharge volume, how much is coming out from the road system. Speed or delays, speed again various types of speeds are there, spot speed, specimen speed, average journey speed, stop delays. Many of these terminologies we have already discussed, and many of the things we will discuss also again in subsequent lectures. Trip times, it may be average travel time that is taking for the trips, we can use this one as measure of effectiveness. Sometimes it is rational to use volume to capacity ratio rather than using only volume, because if you say only volume, 2000 vehicle on a single lane road, on a 2-lane road, on a 3-lane road, the effect is totally different. So, instead of using it only as the volume, it is more rational and logical probably to use a measure like volume to capacity ratio. You know what is the relative loading or what is the relative demand on that road as compared to the capacity, or to what extent the road system is loaded. So, volume to capacity ratio. Sometimes one can use aggregate system measures like total travel time, vehicle kilometer travelled, person kilometer travelled, vehicle kilometer delay also. All these can be measures and can be considered, and they are basically indicating aggregate system measures. There are other measures, for example, vehicle occupancy, the queue length. Queue length is particularly relevant when you have signalized intersection. Maybe the performance of the signalized intersection you can measure in terms of what is the queue length that you are getting during the peak hours, maybe, or the peak periods. Again, the queue lengths may be measured in terms of average queue length, maybe what is the maximum queue length. Sometimes you use measures like number of stops that is made during a journey. So, all these are used as quantities or quantitative measures for, and many of these are also used for defining the level of service. Now, coming to the concept of transportation systems management, already we have created a background for transportation systems management. This essentially means application of methods and procedures for increasing the efficiency and utilization of existing facilities. Remember that it is consistent with the emphasis on making better use of existing resources rather than planning on major new construction. Because remember that if you are thinking of adding supply side as the only measure for solving congestion problem or transportation problem, it is a capital intensive approach, it takes money. So, in majority of the developing countries we have serious financial constraints also. So, this kind of approaches may be more meaningful, because they try to, through this we can try to ensure a better utilization of existing facilities rather than just building roads and enhancing capacity. So, objective of TSM is essentially to shift the focus from high capital approaches to low cost, more rapidly implementable projects. Let me tell you that in developing country context, these kinds of transportation systems management TSM techniques have got a very vital role to play, because we have limited resources. Our cities, in majority of the cases, they are not properly planned. So, it is very difficult even to construct road, to widen road, because of the all around establishments, buildings and other permanent structures. So, this TSM techniques can really be very much instrumental for improving the overall traffic operations in urban areas, and they are low cost techniques and more rapidly implementable technique. You need willingness to accept and implement such techniques in reality. The range of projects considered under TSM, I have already given a background or understanding. So, let us look some of this range of projects that may be considered: exclusive bus lane, high occupancy lane, transit ways, transit management improvement programs, residential parking permit program, innovative bus subsidies. So, bus subsidies also, but it has to be innovative bus subsidies, basically to encourage or in the line of the transportation system management strategies. Bus signal priorities. Okay. So, you can see that majority of these types of project, they are actually intended to encourage the use of mass transportation system through some measures, either directly or indirectly. So, encourage people to use more and more mass transportation systems rather than own personal vehicles. So, the TSM concept represents a fundamental shift in emphasis from build more to use it better orientation. So, it is a shift in approach from build more to use it better. Now, let us quickly look at the components of traffic system. You have 4 components, basically road user, vehicles, roadways and control devices. Traffic engineers normally have very little or control on these first 2 aspects, road user and vehicles, but certainly they have better control on roadways and control devices. Let us quickly go through these aspects. Road users, you know, human elements separate traffic engineering from most of the other engineering, because human elements are involved in it, driver behavior, user behavior, and that makes it different from most of the other traditional engineering disciplines. Several critical characteristics of road users may be quantifiable. We say we have no control on road user, but we can certainly take the characteristics of road user and consider them in the roadway design process or transportation engineering design process. For example, perception and reaction time of drivers, visual acuity, both static and dynamic. Most of the cases we check only the static visual acuity, but dynamic visual acuity also may influence the overall behavior. Then other driving characteristics like hearing, psychological factors. So, design should account for all these drivers characteristics. You will see that in geometric design part, we will discuss in details how we can consider these aspects, road users aspect in the design process. Then pedestrian characteristics, they are also important, because traffic engineering is not limited to consideration of only motorists and their vehicles. It must also consider other users of highway system like pedestrians. They are the essential elements of a transportation system or traffic system. So, pedestrian crossing and sideways, even the pedestrian signal, providing pedestrian signal phase wherever it is necessary and appropriate. Then the vehicles, there are a variety of vehicle sizes are there and types of vehicle. So, when we design the road, we consider them in the design process in terms of taking into consideration all these characteristics to design vehicle. Design vehicle is normally the one whose weight, dimensions and operating characteristics are used for deciding the geometric features. Again, we will talk about the design vehicles during our discussion about the geometric design process. Acceleration performance of vehicles, again an essential characteristics that comes into the design process. Braking performance of vehicles, you will see that that is a very vital consideration. We consider the side distance. We will discuss again in details all these aspects in the geometric design part, and you will see how this braking performance is used for making the design elements or design process, particularly the stopping side distance requirement. Coming to the roadways, I have already discussed about the need for functional classification. You will see we try to design the roads to provide safe and efficient movement of persons and goods. So, we go for geometric design. We have a separate module under geometric design, where we will discuss at length about each and every aspect. You will see that we design cross section elements, we design horizontal elements, we design vertical elements, considering the vehicle characteristics, considering the roadway characteristics, and try to make a safer design which will ensure safe and efficient movement of traffic on roads and highways. Finally, the traffic control devices, remember that they are for the communication of traffic laws and regulations to drivers. So, through control devices, we tell drivers about the laws, what they are supposed to do, what they are not supposed to do, and there are different control devices like road markings, traffic signs, traffic signals. And remember that control devices are only measures of transmitting operational rules to drivers. When vehicles are traveling, they all know about the operational rules and regulations through the control devices. Signal will tell the vehicle you should stop now. Signs will tell the vehicle what they are supposed to do and what they are not supposed to do. So, they are the only measures of transmitting operational rules to drivers. So, they must be very clear, easily interpreted and commanding of attention. Shape, color, size of all the signs, all the control devices are very, very important. Finally, the regulatory aspect of control devices must be enforced, so that people do not violate. If the sign is there, they should obey that. If the signal is there, they should obey that, and that is again to be enforced. All these aspects are to be enforced. So, that is again an essential component. Now, let me quickly ask you some of the questions. Why it is meaningful to attempt to influence the travel demand? Discuss different ways of influencing the travel demand. Number 2, explain the necessities for measuring the performance of transportation system. Number 3, explain your understanding about transportation systems management. And the last question is, identify major components of traffic systems. The answers to this question I will discuss after the next lesson or during the next lesson. Thank you.